In this lecture, I'm going to talk about the aim of science. So what is the aim of science? The aim of science, be it the social sciences or the physical sciences, is to develop stable explanations of natural phenomena. These explanations, and what I mean by stable explanations, are explanations that are consistent, that explain a phenomenon on a recurrent basis. These explanations are called theories. So a theory is basically, at its core, a set of interrelated constructs, definitions, and propositions that present a systematic view of a phenomenon by specifying the relationship among variables with the explicit purpose of explaining and predicting phenomenon. So, what we do in a science, or in a theory rather, is we take a set of concepts that present a systematic view, a recurrent view of a phenomenon, and we specify how they're related. And the goal of doing this is to be able to either explain or predict that phenomenon. Let's take the example of a very simple theory that we use in the field of communication. This is something you should have seen in a COM 101 class. It's called uncertainty reduction theory. And what uncertainty reduction theory does is it takes two constructs, one being level of uncertainty and two being information seeking, and it relates it. So here are two constructs or two concepts, uncertainty, information seeking, and it relates it. And the theory basically states that higher the levels of uncertainty, more likely you are to seek information. That's what those two plus signs at the top mean. Higher levels of uncertainty, higher information seeking. Lower levels of uncertainty, lower information seeking. Now think about how this provides a stable explanation of a phenomenon. So think about any situation that involves high uncertainty. Take a situation like going for a new job interview, or going to meet a person for the first time, or coming to a class for the first time. All of these events have high levels of uncertainty, right? So, and what is uncertainty? Uncertainty is a level of anxiety or a level of stress that you physically feel, anxiety that you emotionally feel or cognitively experience as a consequence of these events. And what do you do when you're about to go to a new job or meet a person for the first time? A lot of us look online, perhaps. For some of you, look online for information about that person or about that job or about the course you're going to take, and that's information seeking. So notice that what this theory does is, on a broad basis, it explains the relationship between two concepts, and it's able to explain a series of phenomena, meeting people, going for a job interview, or taking a course on a relatively stable basis, right? And how these theories come about are pretty important, right? This is what we call as the process of scientific discovery, okay? And the process of scientific discovery takes place in one of two ways. And to explain that, I'm going to use two different analogies. The first one is a question. What is the relationship between pigeon droppings and the Big Bang? And here I'm talking about the Big Bang theory, not the television program, but the Big Bang theory. And what is the Big Bang theory? The Big Bang theory basically states that in the beginning of time, so we can go back billions of years ago, the universe was made up of what is called as a singularity. A singularity is one point of infinite density or infinite matter. And something happened where this one point of infinite matter basically collapsed into itself, and the resulting energy was so huge or so large that that point explodes. And when that exploded, we had what is called as the known universe. So that explosion resulted in mass being, hurled all over the universe and creating all the stars, the planets, the galaxies, and the solar systems that we all live in. This is called the Big Bang theory. Now notice that the theory happened billions and billions and billions of years ago, and there really is no way to test this theory, right? Because there is no record of the Big Bang. There's really no way you can see this because this is a theory of the universe. And so the Big Bang theory is an example of a theory that exists that's very hard to test. But it was tested. This is how we know that this is a real event. And to understand this, you have to understand how this thing was tested. And the way it was tested, and what you're looking at on the right, is a microwave a microwave telescope, right? And this is a microwave radio telescope that existed at AT&T's Bell Labs. And in these at this place, there were two scientists, two astrophysicists by the name of Penzias and Wilson. And Penzias and Wilson were given access to this radio telescope. Now, the story goes that Penzias and Wilson, had some time, and they pointed the radio telescope onto the night sky. And if you think about the universe has to be pretty quiet. And for one reason and one reason alone, it's in a vacuum, and sound does not travel in a vacuum. So the universe should be very quiet. And so a radio telescope pointed to the sky should not give us a sound. However, when they pointed this radio telescope up into the sky, they started hearing a humming sound. They moved the radio telescope to different parts of the sky. Still heard a humming sound. And the story goes that since this was a telescope that was not used a lot, they climbed into it to see what was going on, and they saw that there were lots of pigeons and pigeon droppings all over the place. And so Penzias and Wilson clean up the entire radio telescope, trap all the birds and move them out of the place, and do, once again, point the telescope up onto the different parts of the sky. And what they realize is that instead of being quiet, the universe had a humming sound, and it was not the pigeons that were doing it, but it was the sound of the universe. What they realized, what they discovered as a consequence, was what is called as the cosmic background radiation sound. And what the cosmic background radiation sound is it is the sound of the Big Bang Theory. It's the sound of that explosion. And this got Amos Penzias and Robert Wilson the Nobel Prize for being able to demonstrate that there was a sound to the universe, and this sound was the sound of the original explosion of the Big Bang that occurred billions and billions and billions of years ago. Incidentally, if you have an old-fashioned radio which has shortwave channels, you can still hear a humming sound in that shortwave channel as well. So you can also access the sound. And what's interesting is that this is the sound of the universe, and this is the sound of the Big Bang, which permeates almost everything in the universe, the sky around us, the universe around us, including planet Earth. And so the point of this story is that it demonstrates how scientific thinking and scientific discoveries take place. One way in which scientific discoveries take place is through a theory that someone has. Now, in this case, the Big Bang Theory was a theory that some other astrophysicists way before Penzias and Wilson had already talked about. But what's important here is that Penzias and Wilson came up with a series of hypotheses. Some of these were accidental hypotheses, came up with observations, and confirmed it. This kind of thinking is called deductive thinking. So science and scientific discoveries can happen deductively. They can happen through theory, hypothesis testing, observations, and confirmation. There is another way in which scientific thinking and scientific discoveries take place. And to understand that, I'm going to give you another analogy, and that is, what is the relationship between Greek gods and elephants? So, on the left here is a Greek god. And this one, for many of you, anybody who reads a lot of Marvel comics knows, is a Cyclops. A Cyclops is a three-eyed giant god. It's a Greek god, and the legend of Cyclopses go back to the ancient Greeks, and they would have these legends of including giant human beings and three-headed men and three-headed gods and flying horses and all these mythical creatures. And for the longest time, scientists wondered where the Greeks were coming up with, the ancient Greeks were coming up with these kind of ideas. And what they thought for the longest time was that the Greeks just had a very active imagination, and therefore they were making up these stories. It was only recently that a few scientists and archaeologists actually who got into the ruins of ancient Greek temples, what they found was that every one of these archaeological sites were filled with the skulls and bones of prehistoric animals. And these were prehistoric animals that were incredibly large. So these were dinosaur bones, for instance, or these were the bones of elephants. This is an example of a dwarf elephant's skull, an animal that was extinct even before the Greeks where the human civilizations were formed. And what they found was what the Greeks were doing, where they were finding these giant bones and they were putting it together in a way in which they understood the body would look. And therefore they were coming up with creatures that they knew didn't exist, but they were coming up with these mythical creatures, like giant men like Hercules and so on. So here's another way in which science works, right? So science works through observation. In this case, the Greeks observed bones and structures. They were seeing patterns in these, and using these patterns, they came up with a tentative hypotheses that led to a theory. In the same way, archaeologists found through observations, they found bones of prehistoric animals in many of these Greek sites, and from that they saw a pattern. They saw that every one of the famous Greek temples existed in areas which were very rich in paleontological evidence. With that, they came up with a tentative hypothesis, and that hypothesis led to a theory of how or where the Greek gods originated from. So again, notice that inductive thinking is a separate or a distinctly different way than deductive thinking when it comes to discovery. So in deductive thinking, you are as good as your ability to measure, right? So Penzias and Wilson had a radio telescope, and without that radio telescope, they would not have been able to interpret or understand what was going on. Likewise, in inductive thinking, you're as good as the theory you use to interpret your data. For the longest time, many historians, many archaeologists had seen bones at Greek temple sites, but it wasn't until paleontologists got involved in it that they could understand it. So if you don't have good theory to interpret it, there really is not much interpretation you can do based on just observation.